Hello everyone and welcome to Handmade here, the show we code complete game live on stream. Actually, we don't even know, but yesterday we may have finished our sprite sorting first pass. We don't know because we haven't actually gone and passed the requisite information down to it yet from the render layer. We basically wrote the code that is necessary for doing all of the sorting for our sprites in the game. But in order to do that, we decided we needed the rectangular screen space area occupied by the sprite, and that was not something we were traditionally passing to the renderer. So the renderer, although it knows that information, I shouldn't say not passing the renderer. That's not what we were traditionally passing down to the render output layer, the rasterizer, I should say. And so that needs to happen, and it's not particularly difficult to do, but we actually need to do it. So before we can even test our sorting code, and presumably we'll have to debug it as well, and all that good stuff, we're going to need to start passing that information down and making sure we actually know what all the screen space rectangles are for our actual sprites. So let's go ahead and do that now. Can't think of a reason not to. Today is day 306, so if you're going to try and follow along at home, unpack day 305 source code. That's where I'm starting right now, and that is where you should be starting if you want to follow along. All right, so here we go. If you remember where we left off, we don't have any crash bugs or anything like this, but as you can see, all our lovely, lovely sprites are gone. And the reason for that is, of course, we're not even sorting our, since we're not sorting anything correctly, the clear is probably getting sorted to the front or something like this. And so, who knows, anything can happen at that point. So we have no idea what's going on in there at the moment, so we got to start with passing correct data down, see where we are there, and then we'll drop in and start debugging it and make sure that everything is actually working properly once we've got it having data that it can actually use. So let's go into the code here. There's inside render group. We know that we've got the sort key. We know that we call the push render element only 3 times. We call it for bitmaps in the, well, you know what? I'll just show it to you. We call it for bitmaps, for rectangles, and for the clear. So here's the push render element for the bitmap, here's the push element for the rectangle, here's the clear. And since that seems to be going behind my head a lot, I'm going to go ahead and jump over here real quick so that it's easier to see. So for something like the clear, well, for the clear we kind of know what we would need, right? For the clear we know that we're going to take up the entire screen. And so that means that if our algorithm was working properly, that means the clear should always be sorted behind everyone, hopefully, right? Because it will overlap with everything and need to get pushed back behind everything. So when we're talking about the sort key that we're passing here, I'm trying to remember exactly how this worked out. I believe the push render element for the sort key, in here you can see that it's not actually passing screen area, right? So, or not really setting the screen area. That screen area is here. By the way, you'll have to excuse, my typing's going to be a little slow today. I've got my fingers taped up, which I can only use 3 fingers on my left hand, so it makes it a little bit less. Let's use the word evolucent, which is not actually a word, but it's a word that we just made up to mean that it's not as fast as it would be if your fingers weren't taped. So there you go. So let's pretend we were going to start passing the screen area down here, because basically we know that if any render element wants to be sorted, which all of them have to be for correct rendering, we know that we're going to want to have our rectangle, what did I call it, rectangle 2? Is it a rectangle 2i or a rectangle 2? I'm not really entirely certain which one we ended up using. So let's take a look here. We did a rectangle 2. So with the rectangle 2, I want to pass that down as the screen area, and then I want to save it. And now this should give me an error in the code anywhere that I don't currently pass that, which is the 3 places we said before. Of course, I should also jump back up there. Should also put an actual semicolon at the end of the line, because, hey, that's important. All right, and why do I don't want to be on that side of the screen, bro. There we go. So yeah, so here we go, and now we have to go for each of these guys and figure out what it is. Now, the easiest one should be the rectangle, because the rectangle, I mean, here it is, it's actually doing that information. It's got, you know, it's got the rectangle itself, because that's exactly what it's going to fill. So presumably, when we do push render element here, it should be fairly straightforward to go, okay, we know what the rectangle is that we're trying to fill. Let's just go ahead and make it happen. Now, I don't really have to guess about what that is, because presumably if I went into the OpenGL code here and just took a look at what I actually do when we get the rectangle, you can see, okay, it's a rectangle from P to P plus entry dim, right? So it's like the two corners. So if I want to create screen area from that, if I want to create you know, one of these, then what I should be able to do is pre-multiply this dim here, right? So this is scaled dim. Hard to type. With no fingers on. So scale dim is going to be computed here. Screen area is going to be a rectangle min-max. And that rectangle min-max is going to be the scale dim plus the P. But of course, that P should have been transformed first, right? So if you take a look at what happens here, we're going to use the basis P instead. So I want to use that transformed P instead of using the other stuff. Right? So that's, I think, probably the correct screen area. We'll have to verify it, obviously, but that seems correct to me. Now for push bitmap, things are a little more complicated, because for push bitmap, we could be passing an X and a Y axis. So at first, like I did before, where I kind of cheesed out the sprite bound stuff, we could do exactly the same cheesing here just to get things working, but you know, we're probably going to need tighter bounds eventually. Actually, it's going to be the opposite. These bounds will be too tight. They won't extend as far as they probably need to. So I'm going to take a rectangle 2 here for screen area. I'm going to pass that, oops. Yeah, I'm going to pass that through. And then here inside the rectangle screen area part, I'm going to do rectangle min-max. And I'm going to just do exactly the same thing that we were doing before, where we say, like, okay, let's pretend that it's going to be dim basis P and dim basis P plus size. So we'll assume that we've got the screen area here, and the reason that this is not going to be quite right, just to sort of give you a little background on that if you're not sure. So, oops. So what's going to happen is, in the case where we're drawing a regular sprite, this will be correct. So if we know that we've got an x-axis of 1, 0 and a y-axis of 0, 1, and we don't have to worry about any rotational effects, then we know that this is going to be fine. That's actually going to be the screen area of the sprite is going to be given by the P that's transformed plus that size is going to give us the two corners of our bounding box in screen space, and we're good to go. However, if you imagine what happens were this to be rotated, right? So suppose our x-axis were not that. Suppose we had something that had been rotated on its side like this, or furthermore, it could be like sheared a little bit. So it could even be something that's kind of parallelogram-y. Well, now, whatever that size used to be, you know, is maybe pointing to here. Well, that is not actually the rectangle anymore because it's been sort of warped. And so we don't really have any protection here. We're going to have entirely wrong results if this thing's spinning around at all. So for example, let's take the worst possible case where this thing was rotated completely around. We're going to pick this as the rectangle for the screen area, but the actual rectangle is going to be here if we rotated it all the way around, right? Furthermore, the rectangle could be much bigger or much smaller if we just pass bigger values here. So for example, if the x-axis and y-axis were 3 long instead of 1 long, you know, this is how big it would actually appear, but that's how big we would say it was. So it's definitely not going to be acceptable to do this in the long term, and we're going to run into bugs with that, no question, if we leave it like that. But for the moment, we aren't really using that very much. Only the hopping hero really uses that all that much, and so we can get a quick sense of whether the algorithm's working before we tackle that part anymore. So let's start with that, but we'll want to come back to that soon. Okay, so yeah, I don't remember what we called that function. So we're gonna kind of have to look it up. Oh, it's rect min. Oh, so we can actually do a rect min dim. We've got a utility function that actually just does this automatically for us. So rect min dim is better anyway. So that's great. Two-dimensional parents for push render element does not take 4 arguments. Thought sprite bound screen area. Where's my push? What did I do here? Ah, forgot to add to the macro. Add it to the macro. I added it to the macro. People, you know, who play Dota may have impeccable micro, but here on Handmade Hero we have impeccable macro. I'm gonna go ahead and pass that down. And I think we're all good now. All we have to do is come up with a fake rectangle for our clear, which should be the rectangle that represents the entire screen, right? And I'm hoping that that's actually not too hard to come by, because presumably if we have a render group, that's going to have to know stuff like what the bounds of the entire screen are. So I would think that we would have a way of figuring that out. And it looks like, so we do have an active camera transform which tells us what the screen center is. Unfortunately, there we go. And we have the monitor half dim in meters. So I suppose if we do meters to pixels on that, then we would be able to figure out what our screen rectangle actually is. However, that does seem a little bit draconian, and in screen space you'd think that we would just be sort of storing what that actually is. So I'm going to say, rather than, you know, dealing with all of that, I feel like it'd be fairly easy to just do like screen area here, right? Or something like that. I feel like that would be relatively straightforward. But you know what? No, I think that's fine. So I'm just going to say let's go ahead and pass the screen area down here, and then what we'll do is we'll just initialize that when we initially create the render group, and then we'll just know that we always have a valid screen area that we can use, because I'm pretty sure we just know that information at startup. We just don't tend to preserve it. Now, where was my almost there? Thought we had. Does the render group just get cleared to 0? No, it can't. This has to be set properly. So where were we setting that? What am I missing? We must set that information somewhere. I must have moved it somewhere accidentally. Where did it go? Well, since I still have not written a find for forecoder yet, let's do it here. Monitor half dim. Ah! Flog those hamsters, Microsoft. You can do it. It looks to me like we just don't ever initialize it at all. Maybe that's true. I guess let's find out. So if I want to find out, I'm just going to go to Handmade Render Group. Here where we actually create one of them. So this gets past update and render world gets past that from... So does the render group actually come all the way down? It's been a long time since we've been working on this code. There was quite a break. So I kind of forget some of the decisions we made. Oh, there we go. So it's right there. What am I... Yeah. Was my search not working, or was I must have been typing something wrong. Because for some reason, when I tried to search for this, we didn't end up jumping to it. I must have gotten a little bit backwards for some reason. So begin render group is what I actually wanted to look at, right? This was the function that I was actually talking about. And I feel like that should be here in rendergroup.cbp, right? But it's not. And so that's a little bit weird. All right, so let's find out, where did that go? Did I accidentally misplace it? What is going on? I just did that search, did I not? So there's me searching for begin render group. And it like can't find it. Oh, because I'm not in render group. There we go. So what's interesting about this to me is, it implies, I guess it is true. So even though perspective actually sets the monitor half dim in meters kind of down here, which is a little bit strange. I'm kind of weirded out by that, but that's okay. Anyway, that was a little bit of an aside. I apologize for that. Anyway, point being, inside begin render group, we should have some way to figure out what the actual, and I guess now that I look at it, it seems like we only actually pass this to perspective or orthographic. We pass the pixel height and the pixel width. I don't actually know why that was our decision. We may want to revisit that because it seems like that should be there on startup, but either way, when we do this, we can then therefore set a rect min dim here, where we just say like, oh, okay, it's 0, 0 to, you know, pixel width, pixel height. And I don't know if we can v2i that, can we? We can. So this will set that in both cases so that we have that information around for the clear. And now I think we are passing our sort always down correctly, right? So that should be good. Okay. So now we have to actually start debugging our actual code, because now we've got actual screen areas that somebody set to something that means something. So let's start by taking a look at these. So our screen areas should have something in them that we find plausible. These are in, you know, basically in pixels. And so we should be able to see something here that we think might be plausibly a pixel value. And, you know, I don't know, we'll find out. So, yeah, like, that looks kind of wrong to me, right? Like I feel like that can't possibly be a correct screen area value. I mean, what would we be passing that would have such a ridiculous coordinate, right? Negative 2076 to 8, right? So it's like basically the whole, it's like a giant thing the size of an entire screen off to the left of us. Like, I don't know, that doesn't seem particularly logical. On the other hand, it's possible that that's just because there's something that's very large in Z that's close to us that could have gotten blown out. I suppose that is, you know, a theoretical possibility. So we could look at the sort key and see what it is. So its Zmax is actually 0, which would be right at the camera. I feel like we're going to have to throw things away that are that close because we can't really be handing all of those to our sort. So to a certain extent, that seems like a bit of a problem. And in fact, I'm going to take a look at that. I'm going to take a look at that right here. So we have our entity basis p result situation here where we have result valid equals true. And then here we have result valid equals true. Distance to pz greater than near clip plane. So I guess the thing that I'm wondering is the near clip plane is almost certainly set, so that 0 would get clipped out of it, right? But in this case, it looks like it's not doing that. So that does seem a little bit weird. Now that could be just because the values that we're using for z are not accurate, let's say, maybe. But that just strikes me as a little bit odd. We can close this note too. Okay. That definitely strikes me as odd. So I want to see, I want to see a couple things about that actually. But I definitely want to kind of get some idea here of who we're actually dealing with. Let's take a look at B. Yeah. Yeah, that makes me uncomfortable. That's not great. Where are we at here, by the way, also? Is this just the first pair? Okay, now we're all the way up till the sort of the latest set. I'm not sure what I want to debug first. I can obviously go after the part we're at right now, but I'm kind of just disquieted by those values, and I want to make sure that I understand where they're coming from. And I don't feel like I really do right now. So I'm going to try to take a look at what's going on with those, and I'm going to say, yeah, I'm going to say probably the best way to do that is to maybe take a look at the place where we're pushing render elements and say that inside here it's relatively cheap for me to, oops, that's not where I want to be. Inside here, it's relatively cheap for me to do something where I look at what the area is that's passed in, so this screen area rectangle, right? I could do something where I say like assert get area of that screen area rectangle is, less than, 2000 by 2000 or something like this. And I guess I don't know if we actually implemented an area. Get clamped rect area, has area. So it looks like we never really implemented an area function for these guys, but I'm going to throw one in here. So for this guy, it would be inline v2 get area, and here's a rectangle 2. And obviously the area of a rectangle is just the width times the height. So the result here is really straightforward. It's just like, what's the width? And what's the height? We have those, yes? Oh, no, we don't. We just have getDim. So that's just the computation for the area, right? Nothing particularly unusual there. And if I actually don't make a typo. And in theory, that should give us what we need. Man, I am just a mess today. I think having the flipper hand is not helping. So I'm hoping that this assertion will just fire when we get one of these particularly large screen areas. The reason that I wanted to do that is because I don't really want to have to debug it so far down the line, right? So I wanted to be able to break when I have one of these giant rectangles, because now, now I can just go ahead and set the next statement here. I can step out, right? And I can see who it was that was actually causing this to occur, right? Like who is actually calling this function. And obviously we're going to have this same problem, unfortunately, a couple more times. I could probably skip the last push. Okay. So I actually didn't want to go further at the moment, but that's okay. So it's this part right here that's causing it. So I guess, you know, I guess I was worried for not in this case. Those actually are valid. Like those should be that big. That's actually true. So I'm okay with that because those are our giant sort of world pens, the things that we draw to show where the simulation region is. So I suppose that isn't actually concerning. That's a valid rectangle. I'm not going to freak out about it. I'm gonna say that's okay. So let me go ahead and turn that guy off. And I'm now just going to look at the actual bug. But I was a little nervous about that, and I just wanted to make sure I was not nuts. All right, so for some reason we have disabled the push struct there, I guess because we hadn't finished yet. So that looks like just a case of us having to re-comment in the code, right? So that's not particularly exciting. That might be the only problem there. I doubt it, but it might be. Right. Okay. All right, so couple things about this. First of all, I really don't know what we're looking at, but you can see we're running incredibly slowly, right? And one of the things about running incredibly slowly is I'm assuming, and I don't know, but that I'm assuming it's running incredibly slowly for the reason that I talked about before, which is that we can't leave an n-squared loop with this many elements going through it. So I'm assuming that if we look to see what takes all the time, it's going to be build sprite graph. But I don't know that for sure. So let's first actually do that, because I want to make sure that we actually do know what's going on for this entire process as we do the work of actually getting this correct. Let's time each of these for the walk sprite graph portion and the build sprite graph portion. And also, I'll go ahead and turn on, while I'm at it, I'll turn on, where are you? There we go. I will turn on our debug view, which Handmade internal is actually on. So I'm assuming that means it's still on, but it's just not sorting to the front. Am I right about that? Oh, the horror. We can't actually see. Of course, the hilarious thing is how much faster release mode runs. But yeah, we can't actually see our debug HUD overlay because it's kind of stuck to the bottom. Sorting in the render engine, obviously kind of really annoying because you can see the screen's just a mess. And until we get the sort working, our debug overlay display won't be correct either. So that's kind of a little bit of a slap in the face there. But we're not completely without ways that we can fix that. One thing we can do is I can sort of make it so that our debug overlay puts itself in a better position where we might be able to take a look at it. Since I only wanted to look at the speed, I guess I'll postpone that for a little bit, just to see if we can't get the sort working a little more correctly first, and then maybe our debug thing will pop to the front. I wanted to take a look at the speed originally, but looks like maybe that's not in the cards. All right, I was surprised with how fast that ran with optimizations on, but we'll take a little look at that in the future. So as we can see, we're still not really getting correct sorting results at all here. And in fact, we're getting some pretty non sequitur things. Like, for example, we have, this big, obviously in front thing sorting behind this, obviously not in front thing. What is interesting about this is the sort does seem a lot more stable in a lot of cases. Like, we're not getting a lot of flickering and stuff, but we are still getting some. And so, I don't know. But either way, we obviously need to figure out why we're not getting sort of a reasonable sort out of it. And the only way I think we could reasonably do this, because there's too much stuff on the screen right now, I think what we need to do is maybe like turn off a lot of what we're doing and just focus on rendering a couple things and seeing what happens with those few things, right? So what I might say is, well, okay, we've got update and render world here. Maybe I'll switch back inside, I think it's in Handmade CPP. Maybe I'll switch back to doing the title sequence. The title sequence is kind of nice because it's just a bunch of big fat plates, right? There's not thousands of things going on. And so maybe we can take a look at how the sorting routine performs on these, and that will help us. Now, of course, one thing that's not great is these actually appear to be sorting somewhat properly, so that's less good. It would have been nice if the first one was completely trashed, but it looks like these are doing what they should do. So yeah, but I'm still going to step through them and see what we can see. I would also point out that these are sorting very reliably incorrect. You can see the drop shadow is sorting in front of the regular text. And so it's kind of interesting to me, just one of the things that's a little bit odd is it's interesting to me that the sort is working reliably for the background layers here, and it's working unreliably, exactly the opposite of what it should do for the text, right? For the UI overlay. Now, one thing I'd mention is if you look at build sprite graph, it's taking all the time. That's exactly what I had suggested would happen. That's where the n squared comes in. And so that's good. That's exactly what we want to see because we know how to optimize that, and we can trivially make that much, much faster. So as long as that continues to be the case with the sort, that the only problem is building the sprite graph, we're going to be happy campers because that means we're really not going to have to worry too much when it comes time to optimize it. We know exactly what we need to do. If that changes, it's not so good. All right. So I'm trying to see here, like, do any of these ever render wrong, or are all of the backgrounds rendering correctly at the moment? I mean, that all looks real good. I'm not seeing a lot of errors here. And I'm not sure why. Come on, Krampus. Nah, Krampus is rendering correctly, it looks like. Well, all right. Well, unfortunately, those are working. And I guess it's weird to say that unfortunately it's working, but, that's, what can I say? I guess one thing I could do is see if it's dependent on the ordering in here. I could go ahead and say, well, if we've got intro layers 1 or whatever it is here, what if I, permuted the order a little bit here? So what if I took and I moved 8, up to the front? Is it just rendering? Is it because they happen to already be in the correct sort order? Is that why it's rendering them properly? Or what's happening? Okay, so that's good. So it looks like our sort is just a little busted right now, and it's not doing what it's supposed to do because you can see here, it was just because these happen to be in the right order. I had a hunch that might be the case. That's why I tried that, and it turns out I was right. So that's great. Now we have a case where we can actually take a look at what's happening in the code that's very simple. I can also go in and turn off Handmade internal. So I can go into the build.bat. I can turn off sort of our debug code, right? And what that means is now we're in a really nice situation, because now when I'm running, the number of things on the screen right now is really tiny, right? It's just a few bitmaps that I know are being blit in the wrong order. So I can set a breakpoint here, and I can probably actually step through all 8 of these things and see what the values are, and just figure out whether we're making correct determinations about them or not, right? So let's take a look at what we actually see here. So here we have an A and a B. Now we know that these two are going to overlap each other, I believe. What's a little bit weird is they both look like they have the exact same screen area, which I'll be honest doesn't make sense to me. Oh, fantastic. Well, this is probably has nothing to do with anything bug-wise. Oh, well, actually, it might. But that's just we have a comparison bug there. You're never really supposed to compare something to itself, and yet we totally were. Do you see how this, we wrote this here? We got node index A goes from 0 to the input node count. Well, we start off by comparing A with itself, right? We take whatever the index is that we're on, and we're going to make node B be that. So we're going to ask whether a thing intersects itself, and we're going to get back yes, and then we're going to add an in front of edge in one direction or the other from a node to itself. That actually creates an immediate cycle and is a problem. So, you know, that actually is something we need to fix immediately. That's definitely a bug and not a good and a bad one, right? Not great, not good. So now let me just see what happens, just so I now know also what our target is. Okay, so same problem, no change, so that's good. But now at least I should be able to look at an A and a B and see that they're different. And they are, which is what I wanted to see. So we should know, and then like I'll verify this with a sort key, but what we should see here is, and we do, we should see that B is, well, okay, so let me take you back to this code here. Where is it at? There it is. Okay. So I guess one thing that's a little bit confusing here is if these are rendered in order, meaning if we go through and put them in order, we push from the back of the stack down, the render stack down, to create our sort keys. So it means that we're probably going to see this guy and this guy in order, right? The first person we're going to see is this, second person we're going to see is this. So actually this guy is not involved in the sort right now, in this comparison. I think it's going to be these two guys, right? That's my assumption. Anyway. But so if we see them, we know that the way that we wanted these things sorted was we want the higher z values, right? The things, because the y's aren't really that relevant in this case. So we're taking a look strictly at z values here, presumably. Although I guess the other thing that we have to figure out here is, are these set to upright or not? I assume they're going to be set to upright equals false, but we can verify that in a second. Meaning, are these z sprites? Yes, these are z sprites. So that's what we would have wanted. So that's fine. So we've got the z maxes for these two guys. One is -39, one is -29. And so what we want to see in this case is we want to see the higher z value be in front. So A is the higher z value. We want to see A be the thing that, we want A to come out in front. We want to see them intersect. They do, so that's good. We take the two indices. We say A's in front, B's in back at the moment. That happens to be the correct sort order, the initial guess. So we don't want to swap them here. And we don't, so that's good. We create a new edge. We push it on there. We take a look at what the front, whatever the front sprite actually is. That's going to be node A. And then we say, well, A is the one in front, B is the one in back here, and then we say, okay, whoever was previously in the slot as the first edge in for the frontmost sprite, it's going to get replaced with our new edge, and we're going to daisy chain these on, right? So that looks roughly correct to me, right? And what we should see when we do this here is we should see only one time when is in front of fails, and that's on the last one, right? That's when that's actually going to happen. And there it is. Yep. And so on this one it flips, and that's because I changed the order of those guys. And so now exactly the same thing is going to happen here, right? We're just going to come through and do exactly the same bit where we create these edges. And so that's all fine. You know, it's not the best. It's an n-squared blowout of stuff, like I said, but you know, that's the part that we'll have to make better later. So once we create those, it looks like we're putting the correct edges in there for the most part. So I think the next thing to do is to take a look at what happens when we walk the graph to figure out why we're not getting what we expect to get, right? So here we go. I'm going to go into walk sprite graph. We're going to prep our things by preparing the out index array. We haven't put anything in it yet. We're going to step through here. We're going to start with the first node. We're going to call recursive walk. We're going to verify that we haven't visited it, and then we're going to say that we have visited it, right? Now this first person here shouldn't have any edges coming into it. It should only have edges going out of it because it's the frontmost thing. So presumably we see a next edge with same front, which we did. We're going to want to walk to whatever the one is that's behind it. And let's just take a look at what that index actually is. All right, here we are on 0. If I step in, we stepped into 6. This is exactly what we would have expected. The reason for that is these get pushed onto that edge list. So what we would expect there is that index 6, which is 0, 1, 2, 3, 4, 5, 6, is this guy right here. Right? Now that guy shouldn't really have any, there's nobody who's more behind than him. So in theory, he shouldn't have any edges, and he doesn't. So the first thing that we tell the renderer to draw, right, is whatever this guy's offset is, if that makes sense. So the first thing that we tell the renderer to draw is number 6. Although, wait, do I have that right? Yeah. I mean, that seems correct. All right. So the first thing that we tell it to draw is number 6. We then do another recursive walk, and this time we've got 5. Now 5 should have an edge that goes to 6 potentially, which is what it does. However, 6 has already been visited, so we skip it, right? So now we're going to write 5 in there. This is looking eerily like it's working correctly, so I'm a little confused as to why we're seeing the results that we are seeing. Again, it'll skip 6 here. So, you know, that looks naively like it did roughly the correct thing. All of these guys should now actually be drawn, so it'll skip all of these because everything is overlapping. So the first graph walk does the correct thing. And similarly, if I look now at out index array, oops. I guess there's not really a lot of way that I can tell exactly what that is, but yeah, I think that does go in the order that I would expect, because they're going to go in increasing order, right? Except for the last one, which we moved, right, which is this guy. So that looks exactly like what I would have expected. Like, exactly. So I have to admit, I'm a little confused about why I'm getting weird results there. That looks like a correct ordered sort to me. And I'm not sure. I'm not sure where I went wrong. So I gotta have to push forward a little bit. Maybe I'll see something in here. I hope so. I don't want to have to leave this as a cliffhanger for the weekend. Let's take a look at the sorted indices array. Yeah, so again, that looks pretty good, right? I mean, that looks to me like what I would expect. I come through here and I say, all right, what's the entry we're on? I'm going to take that's not what I expected to see. Entry, oh, because we overload entry here. That's a little bit of a bizarre catch, but okay. There's that entry. It's 512, 168, 224, 280, 336. So those all look, you know, that all looks quite good to me. So that is quite puzzling, because that looked like everything was working correctly. So I think we're going to have to step it up a notch, because I'm clearly wrong about that. And I'm going to need some way of labeling these things in a way that I can more clearly tell what's going on. So we did have a way of doing this, if I remember correctly. When we do our render entries, and where were those? Let's see. So inside here, we did have a thing for debug tagging, right, when we do Handmade slow. And I don't really know that we have anything in particular right now that we are putting in the debug tag, though. But we can always set a group debug tag as we go. So what I'm going to do inside the intro layers bit here is I'm going to go ahead and just verify what these all are by when we actually, let's see where they are, update, play intro cutscene, render layered scene. So here is our rendering where we loop through each of the scene layers and do our little dance, right? What I want to do here is before we actually issue the bitmap call, I'm going to go ahead and set the render group debug tag to equal the layer index, just so I can verify that I actually know what it was, right? And so, you know, it starts at 1, and so if I go back to my cutscene, I can sort of say which one of these is which. I can look at the debug tag for any entry, and I can see, you know, I can see what it is, if that makes sense. Now similarly, that's going to be a little bit of a pain in the butt for us to read. And the reason for that is because the sort key is not in a good place for that, if that makes sense. Because, sorry, I should say sort key. We're looking at the sort keys, and we don't have access to the render group entry header in a convenient way at that point. But what I can do pretty trivially there is I can just say like, okay, put the debug tag in both of these things, right? And so in the case where we're in the handmade slow path, then when we're putting stuff in here, I can say, well, all right, you know, keep the header and the entry, so I can do it like this, both having the debug tag. There we go. So now if I come through here, I should be able to see this going again the same way, but now the debug tags, I think, well, let me make sure I'm in the right part of the scene here. There we go. Now if I come through here and I take a look at these, I should be able to see the debug tags on them just to make sure. So there's the debug tag of 8. That's exactly what I thought I was going to see, right? Remember I said I think they'll be in reverse order. And so off we go. I don't really care about this because I thought this function was working correctly, so I'm not going to learn anything new by looking at that, unfortunately, at the moment. So what I want to do is look at this when we actually go to build the output order. I just want to see when I do the output, what order do I actually output in? So here we're about to output somebody. And so what I want to know is who is that somebody? So the first thing that we're going to output debug tag wise is debug tag 2. So looking back here at the cutscene, debug tag 2 would be this. That's a perfectly reasonable choice. Debug tag 3 is this. That's exactly what I thought. 4, 5, 6, and when we get to the end, we should output number 8, right? Yeah. I'm sorry, number 1. Yes. So, the only thing that I can think of, well, we'll take a look at one more thing. But so if I go ahead and run, there we go. We're still obviously not getting the correct draw order though, because I'm just seeing this giant thing in my face. So the question is, what if we take a look at it the other way around? So this is how it was before, and it was rendering properly. What does it output in that case? Right? Because now we should see it outputting something something wrong. I mean, we should be able to see it outputting something other than the draw order we saw last time. And so let's take a look at that. So the first thing, oh well, you know what? I think we might be in the gap initially. Let me just make sure we get into the. There we go. So the first thing in outputs is debug tag 1. That's what we'd expect. 2, 3, 4, 5, 6, 7, 8. So in both cases, it seems to be doing exactly what I think it should be doing. So again, this is almost like I talked about yesterday. This is one of those bugs where clearly one of my assumptions is wrong because I have verified that the code does exactly what I wanted the code to do, right? I've looked at what the code's doing and it does what I want. So that means there's something happening that's probably relatively simple, but that I am not remembering or thinking about correctly in terms of how the surrounding code works, such that what I think the correct output of this code is actually doesn't yield the correct results, right? So I have to go kind of figure out what that is. And we're pretty much out of time here, but you know, I'm going to take just a quick look. Now that I've actually verified that that's the case, the interesting thing to me here is sort of looking at how that sort is operating. What's interesting about it is moving the things around. I'm wondering if my indexes are not what I'm thinking they are quite correctly, right? Because if you think about how this code is working, I have this notion of a sort sprite bound, and that's the thing that I'm actually sorting. And at this point, it's gotten a little bit out of hand, like the offset, blah, 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 all that stuff. To a certain extent, I think we can probably simplify this down a little bit after we're done getting this working. But anyway, I've got these sort sprite bounds, and those sort sprite bounds, where they're coming from is inside the render group. When we do a push render element, where's that at? When we do a push render element, we push these in pairs. So I push the header, I push on like the information about the render, the thing that needs to get rendered. And then I create the sort sprite entry for it, and its offset is wherever the push buffer is at the moment. So it's wherever it's this, right? It's where the push buffer actually goes. So that's kind of an index into it. The thing, whatever I'm sorting, that's what's supposed to happen there, right? So I've got all of those guys stacked up, and then when I come into the render portion of things and I'm trying to sort them all, when I do my walk, I'm sort of writing out the index of whomever I'm on's, whatever the offset is that was recorded with that sprite bound, which is just a pointer. It's basically like an offset from the beginning of the push buffer into the thing that actually needs to get rendered, right? So what I'm trying to figure out is, since it looked to me like changing the order in which those things were changing the order of pushing these things clearly changed the result, the rendered result, but did not appear to actually change the order in which I was drawing them. That was really pretty weird. You know what I mean? I'm not sure I understand how that was super possible. Very, very confusing. I know what it was. Right, these don't actually contain the bitmap IDs. So that's actually pretty basic, yeah. So moving this here just means that this, yeah, okay, that makes perfect sense. Since I don't put the bitmap IDs in here, they just correspond directly to the thing that's in the file. Moving this here just basically had the effect of making all the layers be the wrong settings, right? So that's actually not a test I can do. Fortunately, doing that test did make me verify that we actually are doing the correct sorting. So I guess in some sense, now I know the sort is working at least nominally properly. For a bunch of things stacked on top of each other, it worked correctly. That doesn't really tell me why it's failing in the more complex scene, unfortunately. So I guess we're going to have to move up a level of complexity here and start to look at what happens in a more complicated scenario. No one ever said it was going to be easy. Okay, so that's fine. That's actually good. I'm okay with that. It took me a little too long. It's been one of those days. It's taken me a little bit too long, perhaps, to figure out that that's not a cause for concern. But I'm happy we stepped through it and watched it work correctly. So I want to re-enable this stuff, but I need to set us up for next week in order to, because we want, we're going to want to leave ourselves ready to go. For next week, getting the sort stuff debugged and sped up, I want to trim out a bunch of stuff. So instead of, all those extra screens, I'm just going to do one screen first. Because, and this is what I assumed too would be the case, just on this one screen, the sorting is wrong, right? So hopefully we can now kind of, winnow away the number of things that are going on here to make it so that we can quickly test the sorting in some easier way, right? So if I look at what's happening, first of all, I could do some fairly straightforward stuff. Trying to see here. When we do add standard room and add wall and all that stuff, I'm thinking maybe one thing I could do is say, well, okay, obviously I can if zero out all this stuff. So now we just have the hero, right? And it also looks like, well, I'm interested to know. If I go into standard room and I remove all the Z tiles, I'm interested to know what happens. So let's see here. So in here, while we are adding stuff, if I just say, you know what, don't ever actually create any grounded entities, please. That is not what I would have expected. So somehow there are no clip recs all of a sudden. I'm not exactly sure why not. Tell me more. Because presumably there should always be at least one clip rect, right? Or is it not the case that we always push a clip rect on at the outset? Well, let's take a look. So inside Handmade render group, when we do begin render group, what do we do about clip recs? And I guess the other question is clip rec 0 something that we were special casing before in some other way? So it does look like we always expected there to be at least one clip rect, right? And it looks like when we do perspective or orthographic, we always at least push one clip rect on. So I'm not sure exactly why. That suggests that nobody is ever actually calling perspective or orthographic. So I'm kind of interested to see, since I know perspective should be getting called, how did we end up with no clip recs? So there's current clip rec index, right? We push the clip rect on there. We come through here and we do whatever it is we're doing. And we can even see what would it be? Render group. So where's the commands? There's the commands. So you can see the commands here. Here's the current clip rect count is 1. So when we come through here, let's go ahead and skip to the end. We've got 8 clip recs. We're going to come through here after having done that, and temporary memory, checking our arenas. All is good there. Output some sound, not like we played anything. And then that works fine. Okay. So now what? Is it the second time through that we crash? I guess. So I know that I'm passing in the render commands here. They'll start out with no clip recs, right? So I guess what happens there is if I remove everything that the hero could possibly stand on, I guess the hero can't be added, so we pop back out, and I'm assuming that means we sort of exit the cutscene here, and we end up in a state where we do play title screen. And I'm not sure. I guess I don't know why we would ever get a case where nobody calls a clip rect push. Like at some point, presumably, someone is going to call perspective. But I guess maybe not always. And apparently that's my bad. That's on me. Update and render title screen. It does a clear here. But you know what's interesting? It never actually sets the screen, does it? It's getting the render group from somebody else. So the question is, did the render group ever actually have like any kind of orthographic anything called? I guess it doesn't. So this is just a straight up bug, actually. I don't really love the way that works. I feel like that's really error prone. I feel like to a certain degree, when we call begin render group, I'm not really sure I understand why begin render group can't be the thing that takes the screen size, right? Like I don't really know why that is. And if we take a look at the pixel width stuff, I guess it's just because we didn't want to save it, but there's no real reason why we can't save that information. You know what I mean? So it kind of feels like that wants to be something that just gets initialized properly inside begin render group. Like it seems like that wants to move here. So I think I'm just going to move it here and see if there's any reason why we can't do that, if that makes sense. Especially since the screen area never actually changes, right? It's not like that's something that changes depending on which projection we're using. The screen area stays the screen area. And so here, you know, if these functions want to know that piece of information, well, they can get it pretty easily, right? It can easily get the pixel width. Yeah. Or the pixel height. Without really having to do much work. It can just say, oh, that's the render group. Like so. Yeah. And I guess these don't have any real reason not to be R2s. So that seems reasonable to me. Let's see if the rest of the code agrees, because I don't know if it does. And then furthermore, that means this can just automatically do the push clip rect at the outset. And now we're not in an invalid state ever, which is much better. None of the 3 overloads. Oh, is that so? Better? Apparently not. Oh. You were talking about this, weren't you? There we go. That doesn't need to happen anymore. So perspective now doesn't need to do that. Orthographic doesn't need to do that. Yeah. And so we need, oh, well, that's right below us there. We just need render commands width. So that just seems better all around. Now we still have the fact that I deleted everything that our hero could possibly stand on, which isn't going to be good. It's going to kick us out of the main game code, so that's a problem. But at least we found a bug in the process. You gotta make things a little cleaner now and then. if I pop back now to where we were doing this and I go to add standard room, I'm going to go ahead and give our hero one thing to stand on. That's because I'm a very generous person, obviously. I'm going to let him stand on one thing. So I'm going to say, well, okay, get rid of the else clause, but give him the one tile at 2, 2. And there we go. So the interesting thing to note, and this is why I wanted to run this test, is it appears that our sort is handling our Y sprites just fine. Like you'll notice the whole left and right side of the screen, the trees are all correct. On the other hand, our Z sprites are all messed up. So that tells me a piece of information that I wanted to know. So I think we'll be able to make a little bit more progress on this pretty soon, but I'm way over time, so I'm going to end it now. Okay. Sorry, I don't really have much time for Q&A. I'm way over time. But I'm glad we got that straightened out there. All right. So let's defer questions until Monday when I'll have a chance to kind of go over things a little bit more. But it looks like everything is now in reasonable shape. And I think the sort is sort of working, but I think we have our Z comparison a little bit wrong. So I think we should be able to kind of like get that corrected in not too much time. Anyway, thank you very much for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org. It comes with a source code. And so if you want to follow along, that's a great way to do it. We also have a forum site you can go to if you want to ask questions, a Patreon page if you want to support the video series. We also have a schedule about the tweets, schedule you, and a past episodes guide if you're trying to catch up on old editions of the series. We'll be back here next week, probably starting Monday. Check the tweet bot if you do want to know when that is. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.